Hello everyone, this is Anupriya, Assistant Professor from Department of Electronics and Communication Engineering, Sri Ramakrishna Engineering College, Coimbatore. So in this session, we are going to explore the architecture of QNX Neutrino real-time operating system. Now, this real-time operating system is widely used in the real-world applications such as automated infotainment systems, industrial automation, and even the medical devices. So, understanding this architecture is very important if you are working in an embedded system or working in any real-time applications. Okay. Now let us see the overview of this session. So we'll begin with what we are going to learn in this session. First, we'll understand the older architectures like executive systems and also the monolithic kernels. After then, we will move on to the microkernel architecture, which is used in QNX. After that, we will also discuss how the processes communicate with each other using the inter-process communication. And finally, we will understand how the process and threads work inside the system. So now let us see the traditional executive architecture. In traditional executive architecture, all the components run in the same memory space. This means applications, drivers, OS are all mixed together. Now imagine a simple embedded system like an old washing machine controller. So if one module fails in this controller, like the sensor module, for example, if we say the entire system may stop working. So this is the major limitation of this architecture. Okay, everything is tightly coupled. A bit debugging also becomes very difficult. Now we'll move on to the second type, that is monolithic kernel. So in the monolithic kernel, this is somewhat improvisation of the previous thing. Here the kernel is separated from the user application. However, the device drivers are still run inside the kernel. Hence, here also the debugging and maintenance becomes more complex. Okay. For example, if you are taking a desktop which is operating like older version of Linux, if a device driver getting failed, then the system crashes. Entire system is getting crashed. Okay. Now let us move on to the microkernel architecture, where which serves as a core concept of this QNX systems. Here, the kernel is kept very small and minimal, which is very important. And only the essential services like scheduling and the communication are inside the kernel. All other services such as file systems, drivers, and networking run as a separate process outside the kernel. Now consider modern car infotainment system. Even if the sound system crashes, what happens? Nothing will happen. Okay, the navigation and the other braking system should not be getting affected, so that will continue their processes. So this is exactly what the microkernel architecture ensures that. Now we'll see about the fault isolation, which means the kernel is getting isolated from all other processes. This is one of the biggest advantages of the microkernel architecture. So let us take some real world example. In the same car infotainment systems, if a Bluetooth module fails, the entire system should not stop working. We Normally we all experience that the driver should still be able to use the navigation or the climate control. So in QNX, when services run independently, failure in one service does not affect the other. Okay, so this slide will tells you the how the inter-process communication happens. Okay, so in QNX, communication happens mainly through the message passing. So this means one process sends a message and other process receives and responds. It simply uses send and receive concept. So the other mechanism, which includes pulses, signals, and post message queues, which all will be seen one by one in the upcoming videos. Okay. So when we talk about the inter-process communication, if you are taking a real-time example in an industrial automation system, if we take a sensor process sends data to a controller process. The controller then sends the command to an actuator. All this communication happens securely and safely using this IPC. Okay. So the next thing is POSIX and Proctento. This process is nothing but it is a standard, and the QNX is always follows the POSIX complaints. So this POSIX uses a this QNX uses a component which is called Proctento component. So this Proctento is nothing but it is the combination of microkernel and the process manager into a single unit. Okay. This also supports the programming like ANSI C and C++. So the developers who want to become a QNX or TOS developer, so if you are very well in C, you will be easily can develop your own applications and deploy that applications. Next is microkernel services. Okay, the microkernel provides essential services like real-time services. These includes the thread management, scheduling, synchronization, timers, and interrupts. So everything, each and every concept is very very important, and we will see each and every one in very clear manner in the following videos. Okay, and now this video is a very introductory video about the QNX architecture. So we will see something about the process model. Okay, the process is basically called a container of resources. It owns memory, file descriptors, timers, and communication channels. Each process is identified by a unique process ID, which is called PID. Each process operates independently and securely. We have one more component called thread. Okay, so this thread is actually a unit which contains execute codes. Okay, so the threads runs the code and the process manage the resources. So the next slide will tells you the kernel calls. Okay, so how the kernel call flows. When a thread needs a service from the kernel, it makes a kernel call. Actually, the QNX operates in a two mode, which is called user mode and the kernel mode. Whenever the threads wants the service, it will enter into the kernel mode. After completing the task, it returns to the user mode. And the next one is the microkernel threads, so which is internally uses some special threads. These threads includes the interrupt service threads, timer threads, and idle threads. So finally, we will coming to the conclusion of this part. To conclude that this QNX Neutrino uses a microkernel architecture which provides high reliability and the fault tolerance. It ensures that failures are isolated and do not affect the entire system. Okay, this makes it ideal for the applications like wherever the data is crucial, for example, in medical devices, industrial control systems, automation systems, or any automotive components. Okay, so with this, I want to end up this video. I would like to thank all for watching this video. I hope this session will help you to understand the QNX architecture clearly with whatever the real-time examples we have discussed. And if you have any queries, please feel free to comment. Thank you.